Alright, so we're getting ever and ever closer to solving logarithmic equations, or using logs to solve equations, and this is going to be one of the steps in that process. We're going to rewrite logarithmic functions as exponential equivalents and exponential functions as logarithmic equivalents. Now, we've been doing this a little bit already, but we're going to now begin to see some variables in these equations, and we're going to see how we can actually solve them. So let's take a look at this first one. And what I'd like to do, what I'd like to do is go ahead and rewrite. Let me get the right color here. I'm going to rewrite this logarithmic equation as an exponential equivalent. So we know that we can rewrite this as 3 to the 4th power, right? Because a log names an exponent. So that has to be the exponent. This is still called a base. Well, this is what we learned. That is called back when we learned about bases and exponents. And the only other place for the 81 to go is right there. Okay, so this is just a little recap of that. Now let's take a look at this next one, which is really interesting. It has a variable as x, and let's see when we rearrange this into an exponential equivalent, it looks like this. 2 to the 3rd power is x. So you can see that you're already discovering that if we have this as a variable, you already know the answer to this. This is 2 to the 3rd power. Well, gosh, that's just 8, and that's the answer. X is 8. Okay, so you can see how we're already learning to solve these just by rewriting them in a different form. So what I'd like to do is take a look at number 3 and do the same thing. What we're saying is this 5 to the x equals 65. Well, that would just mean that let's just say I'm going to rewrite it in logarithmic form. That would be log base 5, right, of 65 is going to be equal to the exponent x. Now, does this help me? Do I now know more information about the variable x? Well, not really. Okay, so here's what I might do at this point. This is a little bit different. What I might do is go back to the form it was before. And I would ask myself, hey, can I get the 65 into a form of 5 to some power? Could I get it to 5 raised to a particular power, and that would be equal to 65? No, I don't know of a way to do that, right? Not without using, some decimal form. I don't have no idea what it would be. And so here's what we're going to do. We're going to say that this is really all we can do. We can rewrite it like that, but we can't get more information. Notice the directions say to rewrite. So we can't know any more information about the x. In the next section into the 4-3, we'll actually learn how to solve those when we can't get the bases to match. But anyway, we've done what they've asked, which is to rewrite it. Okay, let's take a look at this last one. And we're going to rewrite it in logarithmic form. Now, think about it. This is log base e. Now, I'm not going to leave it with log in there because we know log base e is natural log. But I'm going to go ahead and set this up first. So, there's the 6. And we know a log names an exponent, so that must be the exponent sitting over there. All right. Now, I'm going to change this portion into ln of 6 is equal to x minus 2. Now, at this point, I can actually, even though it didn't say to solve it, I can actually find out what the x value is, and you know, I can do that by just plugging into the calculator. So I may or may not want to do that at this point, but again, if you needed to find out what the value of x is, we would just go in natural log of 6, enter, and there it is, let's say 79. So this will be rewritten as 1.79 roughly, right? And that's that. And so this is x is roughly equal to 3.79. So that's taking it a further step than what the directions said, but that's, as you can see, where we're headed. Okay, so there's rewriting it in a different form, and how that rewriting it to a different form can actually help us solve. And that's where we'll be heading on the next couple of videos. Thanks for watching.